Okay, afternoon folks. I'm back again, your tutor for CIE Mathematics. This time around, I'm presenting a Form 2 activity, which is centered around the following concepts. That's mainly data representation and measures of central attendance, where we're interested in the calculations of mean, median, and mode. We'll also delve into standard and ordinary form, operations in standard form, index form, laws of indices, factorization. So without further ado, let me start. List two different methods of collecting statistical data. I mean, we've got lots of them: observation, surveys, interviews, you name them. But the most basic and common ones um, can put here, pick my pen, um, interviews. You can also talk to questionnaires. I don't know if my spelling is correct, but that's questionnaires. Um, Now we're moving on to presentation of data. We are required to draw the frequency table for the following scores. So what we can do is we can start by noting the score in tabular form. Then below, we will then be interested in how often the value is repeated, that is frequency. So looking at the digits here, looks like the list is 3, followed by 4, we have 5, then 6. So we will check how many times 3 is repeated or is appearing. It's 1, 2, 3. So the frequency of 3 is actually 3 itself. When I'm moving to 4, I can check this 1, 2. So 4 is appearing twice. When I move to 5, 5 is appearing 1, 2, 3 times. Then I'm left with 6, which is obviously appearing 2 times. That's our frequency table for the given values above. Then the next step, we are interested in the calculations involving measures of central attendance, that's mean, median, and mode. So whenever we are dealing with those measures of central attendance, it's advisable to sort our data in ascending order so that we can visualize, should we be interested in finding the mode, which is the highest repetition in terms of frequency, or the median itself. So first thing first, you have to reorder our values in ascending. So I can check here, the smallest looks like it's 9, followed by, if I check there, it looks like it's 11. So it's wise for us to close the values that we have already uh, noted down. I've got 12 and 12. Then I'll close the 12s. I've got 15 and 15. I have 17. So I've sorted my data in order. I've got 1, 2, 3, 4, 5, 6, 7. No, my order is 1, 2, 3, 4, 5, 6, 7. I want to make a mistake. So the first problem I require to calculate the mean. So the mean, when we do our calculation, I will get all the values. Then the result that I get, I divide it by the number of values that I added. For our case is 7. Then I'll put my equal sign here. So here I need my calculator. Let me push it aside. Where can I push it? Looks like I'm running out of space to see the values. Let me check. I've got 9, 11, and 2 12s. So I can say here 9 plus 11 plus 12 plus 12, then plus 15 plus 15 plus 17. Then I check my result here, which I'll divide by the number of values, which are 7. Then the result that I get is 13. So it means my mean or average for this case is 18. Then the next question, I'm required to find the median. Median is the value which is occupying the middle position. And we get it from a formula which says n plus 1 over 2. This is a formula which helps us to locate the position of the median itself. And we saw that earlier, our n is actually 7. So it's 7 plus 1, that's 8 divided by 2. What it means is our median is going to be on the 4th position. So when I count, it's 1, 2, 3, 4. So this is our median. So I can come to say for this data, the median is 12. So proceeding with these problems, state the mode. So we are coming back to our values. Mod is the value which is repeated the most. And for this data, we can see clear that 12 and 15, they are the ones with the highest frequency or repetition. So this data does not have a unique mod. We'll come to say we have 12, we have 15. This scenario is called bimodal because we are having two of the values with the same frequency. Right, moving on, we are now on standard form and indices. Now, with standard form, we want one significant figure. When we say significant, it means it's non-zero. So if we check on our value here, the first significant is 4, then we put our comma 5, 2, multiply by 10 to the power. Now, we check how many steps we moved our comma for it to be between 4 and 5. Now, because we are moving to the right, and this is a smaller digit in terms of its presentation in decimal form. So if I move it's 1, 2, 3, but because it's a smaller value, that's a negative exponent. Now the next one I'm required to write in ordinary form. So ordinary form, we don't want to see the base 10 in the exponent. So in other words, we are removing this comma and this given number of steps. But because the 4 is positive, it means our comma is going to go to the right, which enlarges the value. So it's going to be 6, 3, because the comma was here to move 4 steps. 1, 2, 3, 4 means it will occupy that position. Because there's nothing there, we'll then put zeros like that. So this process needs to be done using a pencil so that when you are done with the location of your comma position, then you erase the pencil so that your work is actually neat. So I'll then come to say, um, let me rewrite the value as 63,000. Then in the next problem, I'm required to do a product. And this product, according to Newton's, these are laws of exponents. The first one, it says numbers, they multiply themselves. So 3 times 4, it will give us a 12 multiplied by 10 to the power. Because this is a product and we have the same base, we add the exponents. That's 5 plus minus 2. And this will give us 12 times 10 to the power. If I say 5 plus minus, once the signs are different, they'll resolve into a negative. So it's as good as 5 minus 2, which will give us a 3. But when we do our calculation like this, we are required to leave our number in standard form. In standard form, we need one significant figure, then we put a comma. Now, if we don't see a comma, it means the comma imaginarily is there. So because we moved it 1 unit to the left, on our exponent, we'll add the step if it's going to the left. So that's 10 to the power. Initially, it was 3, but because it moved 1 step to the left, then finally it becomes a 4. Then the next one, we are required to write the following index form. So in index form, we are bringing in a base and an exponent. So we just check how many times the 2 is repeated. So 2 is repeated thrice, multiplied by the 5, which is appearing once. We also have 7 multiplied by itself 4 times. So in index form, that's 7 to the power 4. Then on the next one, C part, we have got 3 times 3. So 3 is repeated twice and 5 is repeated thrice. That's it in index form. Right, then next we are still on laws of indices. So what we are given here is a problem which needs the first law, which says if our base is the same and we are multiplying, this simplifies to a sum on the exponents. So this will equal a to the power 7. Then the next problem, we are having division where the base is the same. So the second law says we will take the common base x, then we look at the difference on the exponents. So this will simplify again to x to the power 7. Then on C, we are having the third law, which says we have a power raised to another power. So this power will multiply all the powers inside. So I'm having 2y squared all to the power 3. So we don't see a power, it means the power is 1 there. So when 3 opens the bracket, it will be multiplying the exponent. So this will come to be 2 to the power 1 times 3, which will be 3. Then we have y to the power 2 multiplied by 3, because 3 will multiply all the powers. And this finally will simplify to, when we say 2 to the power 3, that's 2 times 2 times 2, which will actually give us 8. And the other part, we have y to the power 2 times 3, that will actually give us a 6. Then moving on to factorization, we are interested in identifying the HCF. I've got 6 and 9. They are both multiples of 3. So 3 becomes the HCF, and we use it to divide both terms. And we do it in order, starting with 6x. If we divide it by 3, it gives us 2x plus, like we pick it there. When we divide 9 by 3, it gives us 3. So we are factored. Then when we move to the B part, B, we have got an expression 12y minus 8y squared. And if I look at 12 and 8, they are both multiples of 4, so 4 becomes an HCF. Then for the variables y and y squared, what we do is we take the common variable y, then we compare the exponents. We did not see an exponent that meant it was a 1. So if I compare 2 and 1, we take the smaller one, which is 1. So it means our HCF is actually 4y. Now, if I divide 12y by 4y, the result is a 3. There is a subtraction sign. If I divide 8y squared by 4y, this will give me 2y. So that's my factors in simpler form. Then the next one is a slightly challenging problem. I've got an expression x squared plus 7x plus 10. Now, the approach that we'll do here is we are going to build two brackets. And for our two brackets, we look at the coefficient here. If the coefficient is 1, it means we initially multiplied x by x. Then we move to the last term, which is 10. So with 10, what we'll do is we'll think of two numbers such that when you multiply them, they give you 10, but when you add them, they give you 7. Those numbers are going to be positive 2 and positive 5. So those are the numbers which will come inside the brackets like that. Then moving to B, where I'm having an expression 2m squared minus 8m. So the procedure is still the same. I've got 2 and 8, and both are multiples of 2, so 2 becomes our HCF. Like we did on the previous one, I've got the variable m, and I don't see an exponent. It means the exponent is a 1 there. So that's the smaller one, which will become our HCF. Then I open my bracket and try 2m squared divided by 2m. The 2's will cancel. Then m squared divided by m. I'll use the second law, where I'll say 2 minus 1 to give me a 1. Minus 8m divided by 2m, that will give me a 4. So that's my factors. Still factorizing, but this time around by grouping. So by grouping, we do it in order. We do it in sets of 2's. So I've got A, B, and A. So I check what's common there. It looks like A is common. Then I open bracket. When I divide AB by A, the result is a B. When I divide A by A, that's a 1. Then I factor the next set. And I start with a plus 3 because I see that 3 is common. Then the process continues. I've got 3b divided by 3. It gives me b plus. When I say 3 divided by 3, it gives me a 1. Now the rule says we'll inspect what's inside the brackets. The moment it's identical, then I'll build two brackets, whereby what's identical will be stored in the second bracket. So for this case, it will be b plus 1. And what remains, it will be accommodated in the first bracket. I've got a here, I've got 3, so they'll be stored in the first bracket. So those will be the factors. I hope my Form 2 class, you found this class interesting. Whenever you have queries or clarity seeking questions, you can always comment on the section below. Thank you.